Hi, this is my video number 10. So in this video I'll talk on the we have cylindrical coordinates and spherical coordinates. Okay, so first what we know about coordinate, we have a Cartesian coordinate, which is in 2 dimension xy, 3 dimension xyz, and we have a polar coordinate, polar coordinate, where we represent the point on xy plane, xy. Let's make angle theta, and the distance from origin to point xy we take r. Then x can be represented as r cos theta, y r sine theta. Of course, from here we have, if you square both sides and add up, so we have x squared plus y squared equal to r squared, meaning that given a point xy, we can find the distance from the origin. So r is square root x squared plus y squared. Of course we have plus minus, but since distance we take only the positive parts. Then we have a cylindrical coordinates. You have seen this many times, so I don't want to go that much detail on that. So then we have cylindrical coordinates. So what is cylindrical coordinates? Basically, if in 2 dimension we have polar coordinate, in 3 dimension we can represent it as a either cylindrical coordinate or spherical coordinate. So for the cylindrical coordinate, so what we have is that if in 3 dimension we have x, y, z, okay, and let's say we have a point somewhere here P, so where this P we represent as x, y, z, x, y, z. Okay, so if you find what x, y, z is, you can project that on xy plane. So we have that, and let's say this point on xy plane make an angle theta with respect to x-axis, and we have, let's make it this z much longer so that I can project that. So this is our z. So those points are f, x, y, z. So and this is r. Okay, so to represent x, y, z as a polar as a cylindrical coordinate. So what is cylindrical coordinate? So basically we have a cylindrical, those cylindrical, and that, so that's the cylindrical that we have. Okay, with height z. So this is its height z. So we have x represented as, so this is r cos theta, this is x, so we have r cos theta, r cos theta. So we have y, this is y, or here this is y. Okay, so r sin theta, r sin theta, and the height z is given as z. Z is equal to z. Okay, so from here we have add up these two and square and add up those two. So we have x squared plus y squared is equal to r squared. And for the angle theta, you can just divide those things. Then we have tangent theta is equal to y over x. So therefore, for the cylindrical coordinate, represented by those r, theta, and z, is given as, we have r squared is equal to x squared plus y squared, and theta represented as tangent inverse of y over x, and z is equal to z. Of course, from here again we have r equal to square root of x squared plus y squared. So the points, so therefore the point P x, y, z can be represented as a point P with coordinates r, theta, and z, where r, theta, z is given here. So this is, we call it as a rectangular coordinates. This is what we call it as a cylindrical coordinate. So this is in the cylindrical coordinate. This is in rectangular or Cartesian coordinate. Okay, so let's see example. Plot the point with cylindrical coordinates. Let's say plot the point with cylindrical coordinate given as 2 pi over 3 and 1, and find its rectangular coordinate, and find its rectangular coordinate. Okay, and the other one is B, find the cylindrical coordinate, which CC as a cylindrical coordinate of the points with rectangular coordinates given as 3, -3, and -7. So in this case, first case here, this is our r, this is our theta, this is our z, and the second case, this is x, y, and z. So what we need to do is, given the cylindrical coordinates, we want to convert or transform into the rectangular coordinates, or given the second case here, given the rectangular coordinates, we want to convert into cylindrical coordinates. Okay, now how to plot those points? How to plot those points? We have x, y, z, and 2/3 pi, which is more than half, right? So we have basically somewhere, let's say somewhere there. So this is your, basically this is your r. This is your angle, 2/3 pi. And then we have r is 2, so this is r equal to 2. And we have z equal to 1, so that equal to 1. Okay, so this is z, 1 is here. So this point is a point, let's give a name here. Let's call P is 2/3 pi and 1. So to convert to the Cartesian coordinates, we have x is given as r cos theta. So you have r cos, our theta is 2 over 3 pi, and 2 over 3 pi, this is we have this is the second quarter, so cos should be negative, so we have 2, this give you negative half, right? So that gives you negative 1, negative 1. Okay, and then for y we have r sine theta. This is our r is 2 sine 2 over 3 pi. Okay, and sine 2 over 3 pi, this is 2 square root 3 over 2. This is equal to square root 3 or sec 3. And for z we have z equal to 1. So therefore we have the cylindrical coordinate 2 over 3 pi 1. This is equal to in rectangular coordinate is -1, sec 3, and 1. Okay, so here of course this is a simple angle, a basic angle. You should know this without using calculator. Yeah, so the angle like theta 0, pi over 2, pi over 3, what else, pi, and so on. Yeah, so this angle, and as well as pi over 4, as well as pi over 4, this is, we call it as a basic angle. All right, so you can find the cos and sine without using a calculator. Okay, now let's see for this. I see for this for the second part of the example, we have those points. We want to change to a cylindrical coordinates. So our point is 3, -3, and 7. Yeah, this is a point in rectangular coordinates. Okay, now to change to the cylindrical coordinates, what we need to find is that we need to find r, theta, and z. Of course, here in this case z is just the same as negative z. So to find r, so we have r is given as square root x squared plus y squared. We know this thing, so this is equal to x squared is 9 plus y squared is 9, so that 18. This is 3 square root 2. Okay, and to find theta, so we have theta is actually tangent inverse y over x. That give you -1. So tangent -1 and tangent -1. So we have, this is so we have negative. You can use this. What is it? SSTC. Okay, saya suka tengok kartun. So negative 3 and -3 is somewhere here. So tangent negative, you got the angle here. Right? So this is 7 over 4 pi, plus, and those points keep on keep on rotating this that's coordinate. So we have plus 2 n pi, yeah, for n equal to, in fact, from 0, 1, 2, and so on. When n equal to 0, we have that basic angle there. And z is minus 7. So therefore x from x, y, z, those points, -3, -3, and -7. Okay, this is, we change to the cylindrical coordinate. We have r, theta, z, which is, our r is 3/2. Our theta is those, just take one basic angle. You can consider that 704 pi, and z is -7. Okay. You see, one point, you remember that because this is a tangent minus 1. If tangent plus 1, this is pi over 4, right? Tangent theta equal to 1, that gives you theta equal to pi over 4. So when theta is negative, when tangent theta is -1, so your theta is what? So pi over 4 is here. Sorry, x-axis. Oh, I changed it. Sorry, this is wrong. So should be here. Saya suka tengok kartun. Okay, so we have sine, all sine, all sine, cos, and tangent. Only sine positive, only tangent positive, only cos positive. So pi over 4 is here. So we need negative. So the negative, it should be here or here. So we have that angle, and we have this angle. So this angle is, of course, negative pi over 4. So you can also choose either this one or the other one is 3 square root 2 negative 1 pi over 4, negative pi over 4, and -7. So we have two points for cylindrical coordinates. Then can give you another example. Find the equation in cylindrical coordinate. Find the equation in cylindrical coordinates for ellipsoid for 4x squared plus 4y squared plus z squared equal to 1. Okay, so since we know that what x squared plus y squared is r, so you can write this, or you can factor out those 4. We have 4 x squared plus y squared plus z squared equal to 1, and this is r. So we have 4 r squared plus z squared equal to 1. You can write in this form, or in other form you can have z squared equal to 1 minus 4r squared. You can also write in either of this form. Next, we look at the cylindrical coordinates. Spherical coordinates, sorry. We look at the spherical coordinates. So what is spherical coordinates? Again, it's in 3 dimension, a point x, y, z, 3 dimension. Okay, so x, y, and z. What you can do in this case is that we represent or assume that we are in a spherical. For example, that how to sketch spherical, how to sketch a sphere. So that's we have those, and we can write those. Now we have a sphere. Okay, so let's assume that we have a point here. This point as x, y, z. Now we want to represent this in the spherical form. So for the spherical form, so this point, if we how to plot this point? So basically, we have the distance from angle from origin. All right, and this point here can be projected, of course, projected into xy plane. XY plane. Let's say that. So this is your x, this is your y, there, and this is your x. Okay, and so we have x here, we have y here, and can you see that? Yeah. And then we have, okay, so this is your r. So this x, y, z make an angle here, theta, and as well as angle here. Let's say this angle phi. And we have the radius of the sphere, that is r. Okay, and we also have, we have the not a radius, but the distance of point xy to the origin, as well as the radius. We call it as rho. So the point xyz in the cylindrical coordinate can be written as in terms of spherical coordinate with, we have rho, theta, and phi. Don't change those things. Okay, where of course our rho is positive, and our phi is between, so this is phi, okay, from 0 to pi, and our theta from 0 to 2 pi. So you may want to think why this is not to 2 pi, just 0 to pi. Yeah, why not 2 pi? We only have pi here. Think about that. Okay, now how to write those points x, y, z as a rho, theta, and phi? Okay, so for x, how to determine x? So we have here, yeah, this point x is r cos theta, So to find r, your r is basically rho cos phi. All right, so I can write r is equal to rho cos phi, rho sin phi, and therefore our x is given as r cos theta, which is our r is rho sin phi cos theta. What about y? Y is r sin theta. Our r is rho sin phi. So we have rho sin phi sin theta. And z is given as, this is your z. Should be z here. Okay, z is rho cos phi. So therefore, the point x, y, z in Cartesian coordinates or rectangular coordinates. This can be written as spherical coordinates with representation of rho, theta, and phi. Okay, don't change the order of that angle. As well as like this, you cannot change the order of, if you like change x, z, y, then basically z is y and y is z. And the same thing with this, so you don't change the range of that. Okay, so from there what we have, we need to find, if you are given x, y, z, then we need to find r, we need to find theta, and we need to find phi. How to find r and theta and phi, and not really r but rho. Okay, so from there it is not difficult to show. You can have those things from this relation 1 to 3 here. Okay, so if you square x squared, square this thing and square those things, that will give you rho squared. You can try those things. So you can try that. So if you write that x squared plus y squared plus z squared, that will give you x squared is rho squared sine squared phi cos squared theta, plus y squared is rho squared sine squared phi sine squared theta, and z squared is rho squared cos squared phi. Okay, then you can factor out all those phi, or goes rho, and factor out rho, so you have rho squared. Okay, what else? You can factor out sine squared, so because you have sine squared there. Okay, you can factor out we have sine squared phi. What left is cos squared theta plus sine squared theta and plus cos phi. This is 1. Alright, so we have rho squared. This is sine squared phi plus cos squared phi. That gives you 1. So we have r squared. So this is one of the relation. We have x squared, or I can write rho squared is equal to x squared plus y squared plus z squared. Meaning that if you are given x, y, z, then you can find what rho is. Okay, then you can find theta. Theta is tangent inverse y over x. What else? You can find phi from there. You can find phi. Once we find rho, you can find phi. Yeah, phi is given as cos z over rho. So let's see few examples how to apply this thing. Yeah. First example is that let's say plot the point 2 pi over 4 pi over 3 and find its rectangular coordinate. Find its rectangular coordinates. So means we want to find x, y, z. Plot, I think you can plot those things. This is in first quadrant. This is also in the first quadrant. So the plot is not difficult. You can do, oh, let's make it straight line. Okay, so you know where theta is. This is rho, so we have rho is positive 2, so let's theta is pi over 4, so pi over 4 somewhere here, let's see. So this is your pi over 4, and then your phi is pi over 3, so we have let's say this is our phi, so this is pi over 3 here, and the distance is 2, then that's our point. This is our point. 2 pi over 4 pi over 3. Now to find the equivalent rectangular matrix, rectangular coordinates given the spherical coordinates, so we need to find what x, y, and z is. Okay, so this is pretty easy to do because it's quite straightforward. X is rho sine phi cos theta, so you can just substitute everything there. Rho is 2, sine phi is pi over 3, and cos pi over 4. So we have 2, sine over 3 is what? Sine over 3 is sec 3 over 2. Okay, and cos pi over 4 is 1 over sec 2. Okay, so simplify this, that give you 3 over 2. Now how to find this thing, right? Using that. For pi over 2, this is we have the adjacent and opposite angle distance is 1, 1. So this is actually pi over 4. So this is a square root 2. You can use the Pythagoras theorem. So from there you can have cos pi over 4, cos pi over 4, this is 1 over sec 2, sine pi over 4, that give you 1 over sec 2, tangent pi over 4, that can give you 1. Okay, so what about this? Pi over 3. Pi over 3 is that 60 degrees, so we have something like that. Alright, so 1 here, 2 here, so we have here is square root, 2 here, this is square root 3. This is pi over 3. So sine that over that, so we have this. If you want to find cos, cos is half. If you find tangent, tangent is sec 3. Okay, so easy. Alright, we have x, then you can find y as well. Y is rho sine phi cos theta, that gives you our rho is 2 sine phi pi over 3, and cos, y is sine, right? Y is sine. The sine pi over 4, that gives you 2 sine pi over 3. Sine pi over 3 is sec 3 over 2, and sine pi over 4, this one 1 over sec 2, that gives you 3 over 2. Then you can find z. Z is rho cos phi, that gives you 2 cos pi over 3, so that gives you 2 half that equal to 1. So therefore, from the given spherical coordinates, 2 pi over 4 pi over 3, this can be written as a rectangular coordinates 3 over 2, 3 over 2, and 1. I'll give you one more example. This example is to change from the cylindrical coordinate to rectangular coordinates. Then now I'll give you an example how to change from the given rectangular coordinates. So example, given the rectangular coordinate which is 0, 2, 3, and minus 2, we want to change it into spherical coordinates. Okay, so this is x, this is y, this is z. So we can find rho, which is given as x squared plus y squared plus z squared. So you substitute into that all those values. So we have 0 plus this one is squared 4 times 3, so you get 12, plus this one is 4, so that's 16, that gives you 4 plus minus 4. Okay, so this is plus minus rho. Can it consider negative? Cannot. You can only consider the positive part. So just take the positive part because rho is the radius of the sphere. You cannot take negative as a radius. So therefore we consider only positive part. And next is to find theta in phi. Okay, so the easiest way from z is rho cos phi. We can find phi more straightforward from here. Okay, so phi is given as cos inverse z over rho. That gives you cos. Our z is minus 2, our rho is 4, so we have cos inverse minus half, so that gives you, this is 3 over 2 pi. Yeah, from here cos half, where is cos half? Here we have pi over 3, but we have negative, so it goes to another so you can write like this. So we have cos that, okay, this is pi over 2, this is 1, this is minus 1, so minus 1, this is 3 over 2 pi. So we have am I right? Should be correct. Yeah, cos phi is cos sine. Okay, that's minus 1, so minus half pi over 3 over 2, sorry, this is 2, sorry, this is not 3 over 2 pi, this is 3 over 2, sorry, not 2 over 3 pi, sorry about that. Okay, 2 over 3 pi, so this is somewhere here, minus half. This is 2 over 3 pi. Okay, use this. Use this, that, and that. Okay. Then, so we have phi. We need to find theta. Theta is we have cos theta is equal to x over rho sine phi. Okay, from where is it? You can use any of this. So we want to find theta. You can use either that one. You can use either that one. So in this case, I use x. First one here. So we have cos theta is equal to x over rho sine phi, because we already found what rho is. We already found what phi is. So from here, cos theta, that gives you x. Our x is 0, so that gives you 0. So this gives us our theta is pi over 2. Okay, so therefore we have 2/3 minus 2 equivalently to 4 pi over 2, and we have 2 over 3 pi. Okay, and another example that involves equation. If you have this equation, y squared minus z squared equal to 1, change into the spherical coordinate. We want to change those equation into spherical coordinates equation in the form of spherical coordinates. So you just use what x, what y is, and what z is. So from there we have rho squared sine squared phi cos squared theta minus rho squared sine squared phi sine squared theta minus rho squared cos squared phi, that's equal to 1. Okay, then you can factor out rho squared, and from these two you can factor out sine. So we have sine squared phi, that give you cos squared minus sine squared theta, and rho we have factored out those. So your left is minus cos squared phi, that equal to 1. Okay, then rho squared sine phi, this is cos 2 theta minus cos squared phi, that equal to 1. So this is your equation. So this equation in rectangular coordinate is transformed into the equation of the spherical coordinate. So they are equivalent, represent the same graph or the same diagram. Okay, so with that example, let me conclude what I have given in this video. I'll talk briefly. I begin briefly with a polar coordinates, since you know what polar coordinate is. Then I give the definition for the cylindrical coordinate as well as a spherical coordinates, and with some example, of course. Yeah, so with that, I thank you. We meet again in the next video. Bye.